let's get started. For this particular session, we want to understand the technology everyone is talking about. So at the end of this session, we should be able to look at any AI news, any job descriptions, any team announcing that, hey, we are building something around AI and actually understand what they are talking about. Not just the words, but we actually understand what they have done. Okay. Okay. So relatable start. So when we say AI, it is something which is already there. We already using AI. For example, nowadays we are using rewriting emails. So we write some draft and ask ChatGPT to rephrase it professionally. While debugging the codes, we add some error, give some context, and ask like, "Hey, can you explain this error and try to fix it?" Even summarizing the document, uploading the PDF and all. Then Instagram captions, something like, or even WhatsApp captions. Okay, we want to upload some photo and we don't know like what caption we should add. So we ask AI, hey, this is the event and I wanted to add some captions. So this is basically an AI version of yourself, right? It's we are already using it, but on the user side of it. We just don't know what exactly happens behind the scene. So let's explore that part. Okay, I will skip the poll. Okay, now the important question like why we are here. Okay, so AI will not replace developers, but developers using AI will replace those who don't. And I think this is the main purpose why I wanted to learn AI and go for it. Right now, if you look at the AI initiatives, it's getting into the news every now and then. Most of the companies are trying to catch up on the AI front. Whether it's be an automation, it's like coding assistants and other like we have seen the news like AI will replace the developers and also it's not really the thing that AI will replace, but as I said, like it's the one who will try to use it will replace the other, and that's for sure. The first one might not be true or might not be sure, but second one is something which we can relate and we can be most of the sure around it. Okay, so let's connect what we already know from the AI stuff. Now, going back to the college days, right? We remember these diagrams like artificial intelligence, then the machine learning, and then the deep learning. We have this subject maybe in the last in year of the engineering, maybe, or maybe a third, I would say third year, right? Where we have these subjects, artificial intelligence, machine learning, and other things. And we have seen these images multiple times, right? So when we say the LLM and other things, where does that particular thing fits in? Okay. So here is the thing. So if you see the difference, generative AI, the one most of the people are talking about, it is actually a part of deep learning itself. So it's not anything which is completely new. It is just the next evolution of what we have already known. Okay. So artificial intelligence is the outer bigger box and it contains the ML, deep learning, and then the generative AI, and it basically contains the LLM. So LLM stands for large language model, and the GPT, Claude, and Gemini are actually the large language models in itself. They are agents, but I will explain you when they started, they were the large language models. Okay, so that's important thing, like how they are connected to the existing technologies that we know. Okay, so I will just brief about some foundations around machine learning. So and how they are differ from other things like deep learning, and then we will move to the generative AI and the LLM part. This is just to understand, I would say, some background to the LLM. We can directly jump into the LLM and Gen AI part, but having a little bit information of machine learning would be a great. Okay, so let's quickly revisit what each layer actually means. Okay, with examples, not the definitions. Now, machine learning. Here is one of the classic example of, well, let's say, fake news detection. So we take a data set of thousands of news articles, label them as a real and fake. Then we train a particular model on that data set. Now the model learns the patterns. What kind of words appear in a fake news, what kind of sentence structure it has, and what are the sources and all. Now, when you give it a new article to that particular machine learning model, which that model has never seen, an entirely new article, it predicts whether the news is real or fake with a confidence, like some percentage confidence. Now you give it, okay, so that's what the prediction part of it, and that part something we called as a machine learning. The key difference from the traditional programming, here we don't write a rule to basically check for certain words and all. It something that it learns by understanding the patterns. Okay, so that's the machine learning for us. So like learning the patterns from the data to make a prediction on a new input. So this is how you can sum it up. More of a machine learning part. Okay, now what is deep learning? Okay, so it is again, if you remember and go back to our earlier slide, you know that it is a part of machine learning itself, but one step ahead. So in machine learning, you have features. So for example, when we say we provide it news, then we provide it a sources, then we provide it the date, then provide it like in which paper it appears. So basically, we try to give a lot of information in the, let's say, a different column perspective. Okay, and we generally call them as a features. Okay, for example, uh, you had tell the model that what to look at for spam detection. You might say check if the email is long, check if it has dollar signs, check if it uses all the caps, right? So you have basically hard coded or handcrafted the features around which the model is thinking about, and model will try to predict something new. So you feed it raw, for example, you feed it a raw images, just a pixel, and let's say it figures out on its own that these pixels form an edge. So these edges forms a shape. These shapes look like a face, and you never had to tell it any of the things. So this is more of a deep learning part. Okay, so I have taken an example of deep learning and the images part, because in images you don't really know what type of feature it is, because though we see image as a, I would say, uh, and a particular image of, let's say, something like a football player or maybe a cat, but at the end of the day it's a pixel having a RGB values. Okay, so it's really hard for us to define the feature. For example, if I give an image to a model and ask like what are the different things you see in that particular images, so in such cases having a machine learning model will be difficult, but the deep learning model will work because it internally learns about the pixel level patterns. It internally learns about the, as I said, like the edges and other things, how they are appearing into the multiple images. So it generally called as a latent feature. So it is something that model understand and model figure it out, and that's why we call it as a deep learning. Is so there is a very good example of the how this particular model learns. It has a multiple layers, and the in between layers are basically a deep forms a deep learning network. So this is just a theory. I don't want you to go into the details and depth of it, but I just want you to understand that for generative AI, it is actually a special case of the deep learning itself. Okay. Okay. Now the generative AI, the one that we wanted to understand. Okay. So just a small recap. Like in case of predictive AI, what was done earlier was like a spam detection, fraud detection, then something like a loan risk scoring and disease diagnosis. So these are something like predictive form of the machine learning or AI. So it's more of into the predicting something. In generative AI, it does not predict. It simply generate the next word and the next token. So whatever we see in a chat GPT or a Claude, It's actually a generative thing. Okay, it even don't understand what should be the next word, but it basically create a list of different words, and it has a weightage to it, and based on the highest weightage it just predict the go on appending the next word, and that's how the sentences are formed. Okay, so it really don't understand, uh, or I would say don't store something which like of FAQs kind of thing or question answer kind of thing, but it simply try to generate the next word. And it same goes for other form of I would say media, like whether it's an image or audio or video. Okay, okay. So let's move on to the large language model part. So this is something which most of the people are talking about. So what exactly the large language model is? That is LLM. Okay. So imagine someone read the entire internet, every Wikipedia article, every book scanned by Google, every post and research paper maybe, or even entire GitHub. Okay, so it's like billions of words, pages, and sentences. Now, as they read, they learn the patterns of the language. So they learn like how sentences are formed. When we say the sky is, it generally think that most of the people like blue after that. So it's try to understand how the words are formed, how the sentences are formed, how they are structured, and that makes an explanation pretty good from the LLM part. So then you ask a question. Let's say when we ask a question which is something like entirely new to that particular model or LLM model, it try to predict the next word, and that's the simple LLM. Okay, so it's think of it as an autocomplete part. So you have seen in a Google search earlier when we even nowadays as well, when we try type for something like nearest petrol, then maybe pump near me or petrol pump, and then you get suggestion like near me. So these are the autocomplete, but that was more of a prediction, but this is more of a generation. Okay, so so ChatGPT, Claude, and Gemini or Llama, these are the LLMs that we heard about. So for example, the on day-to-day basis we use ChatGPT. This is actually a large language model from the OpenAI. So these are the, I would say, vendors, or these are the companies who created and owns these particular models. Claude is from the Anthropic. So Claude is something which making a lot of news nowadays, and this is more of because of the better coding abilities that Claude's recent model has. That's Opus 4.6. Gemini is something from the Google, and Meta is also there. And the best part is all their models and their weights are open source. So all the models like Llama, it has a various size of models like low low models, I mean low size small language models, we call it as SLMs. Large language models like LLMs. When we say large and small, it is mostly depends on the number of weights that particular model has. I mean, I will show these things later, but as of now, just think about whatever we are using, they are actually LLMs, large language models. Okay, they are trained on massive amount of data. Like in current models, they are entirely trained on whatever available on the internet, and that's the reason they know a lot of things. For example, whatever a code that we have written, it's in, let's say, GitHub, so it knows every bit of piece around the code, its structure, the best practice, and other things. And when we ask a question to them, we call it as a prompt, and it predicts something. So I should not say predict, but it generates something based on that prompt, whatever it knows better around that things. Okay, that's how the LLM is. Okay, so yeah, here is the thing. Like when you say the sky is, and even if you enter, it most likely print blue, and then it will not stop at blue, but it will again start predicting something, start generating something else on top of that as well. So this is a mind map you can think of. So it will, let's say, have different words and different weightages assigned. And since blue is occurred 42% of the time in whatever text I have read so far, so let's generate blue. And that's how the models are capable of generating the next word. So as I said, LLM don't understand the text really. They predict or generate the statistically most likely continuation based on the patterns learned from the billions of documents. Okay. So there is nothing like we have trained them on the sky is blue or other words, but we simply ask them to read lot of documents, and by reading this document, it try to generate the next best continuation, and this process repeats word by word until the response is complete. Okay, so under the hood, so this is the simple example. So when we say something like summarize the article, let's say in three bullet points, this particular prompt is then split into words, so generally called as a tokens. So for now you can think of tokens similar to words, but they are slightly different. But for simplicity, consider one word is a token. So when we say summarize this article in three bullets, it actually have, let's say, one, two, three, four, five, six tokens. Okay. Then there is a transformer model. So this is the key. So this part was there earlier, but the transformer model and the attention mechanism is something which clearly distinguish this generative AI models and the LLM models, and they are the reason why we see a lot of success. So you can read about attention mechanism maybe in one of the white paper. That is more of a, I would say, more of a tech heavy part. How this LLM models actually uh, uh, try to pinpoint which word I should use as a next. Okay. For example, when I say the bank by the river versus the bank loan, you can think of both bank and bank in both of the sentences. They have the same token, right? Same word, but their meaning is different. So in the first, it's more of related to the side of the river, and other one, it's more of related to a financial institution. Okay, so the model knows. Okay, so the model knows when we say bank in the context of loan, it is a financial institution, whereas when I say bank in the context of river, it's a side of that particular river. So this is what the attention mechanism, and that's how we also think about, right? For example, whenever we thinking about these two, we know that spelling for both the words are same, but it's the context that differentiate between when should I think about a financial institution versus the other. So similar thing is kept inside the LLM, that is called as a attention mechanism. So just remember that LLM is because of the attention mechanism that they have. They are superior because of the attention mechanism that they have. If there is no attention mechanism, then there wouldn't be any success around the LLM at all. Okay. And whenever we get the output, it simply generate the next word until it feels the end of line. So that end of line is also something the model has seen on most of the data, that after this particular sentence generally dot is there and the sentence is completed. Okay, so everything is just the generation part. So you have seen uh, the LLM part. Now let's think about what exactly triggers that LLM to do that specific things for us. Okay, and it's nothing but the prompting. So prompt engineering. So how you ask question that determines the quality of the answer. For example, whenever you have wanted to get some information from the LLM model, let's say ChatGPT, you write something and the ChatGPT gives you answer, and then you realize it is going into, let's say, some different direction, and then you try to reframe your question in a better way, and then the answer you get from the chat GPT is more close to what you expect, right? So when you try to frame your question in a better way, this is what the prompt engineering is. As I said, like, prompt engineering is something that basically will define the quality of your answer or quality of your response from the LLM. If you ask him a very vague kind of question, the output will be that of that quality. But if you are, let's say, more specific, having a better context, even if you ask it to give it in a certain format, the output will be much more precise and accurate as compared to the previous one. So for example, for us, maybe in the coding kind of way, sometimes we need JSON, okay? So we might ask him to, for create it in a JSON. Maybe we can pass it a particular uh, class structure and ask him to generate output in this particular format. So it's more around what we ask LLM to do, and then it will do the same for us. And I mean, there are multiple hypes around the other things, but remember, prompt engineering is most important and is the only important thing, because there is no other way uh, how we can let how we can increase the quality of your answer unless we have a very specific, very rich prompt. uh, we won't get much clarity from the LLM's output. You can check multiple prompts given by editors, or there are open source prompts. Okay, you can go and see how detailed the prompts are. So it's not just few sentences. Some of the prompts are even a kind of essay you can think of, or a multi-page prompts. And these are you might have seen some example on a LinkedIn that some prompts leaked from, let's say, Microsoft, or let's say some Anthropic. And when you really try to open it and read, you will understand it is not just two or three sentences. It is like one or two page and very much detailed prompt. And it's more of a prompt that is doing the entire magic, not just the question that they are asking. Okay, so uh, yeah. Next is like bad prompt versus good prompt. So this is how the example is. I mean, let's say we wanted to write an email. I mean, when I ask ChatGPT to write an email, it won't get much context, right? It will simply generate something useless thing for us because it do not understand what purpose that email was, to whom, and do we want a professional way or some other way on exactly. But when we ask it in a much better way, like write a polite email declining a meeting invitation, for example, and have a tone like professional, maybe a 5 line is enough, then it will give you much better results. That's actually the prompts. Okay. So when we say bad prompt, good prompt, or simple prompt, it's everything is a prompt engineering. And this is the after LLM, second most important thing is the prompt engineering we should learn. Okay. Next. Yeah, tokens and the cost. I just wanted to have a simple idea that you should have. So whenever we ask, I mean, whenever we try to use some technologies in our existing stack, we need to have some information around how much it will cost us. At least we should have some rough amount of idea around it. So just a simple explanation around it. So as I said, like token considered as a one word. So whatever we ask to the LLM is called as an input to the LLM. Whatever is generated from LLM is called as a output from that LLM. Okay. And now whatever question we ask, let's say it has let's say X number of words. So they are also a cost associated with them. Whatever LLM generate, the number of words or number of tokens, there is also cost associated with that each token. So whatever the input, whatever output we get, everything has a cost. So having a precise prompt, input prompt, and the number of times you ask will increase your cost as well. So remember that whenever you think about using the LLM part or even the simple APIs into your existing application, you should know that whatever you are asking and the responses you are generating, everything is or everything has a cost, some cost associated with it. Now let's see how we can use it. So whenever we see something like there are openings for Gen AI developer and other things, okay, So most of the time, it is simply an API integration that they wanted. Okay, so here is an example. So we know that entire application stack is like UI, it at a front end, maybe Next, React or Angular, anything. Okay, then we have the backend. This is the traditional way. We have backend like Node, Python, Go, anything, maybe Java, Spring Boot, and other things. Then I will skip the third layer, and then we do some processing, and then maybe a database, maybe. Okay, we do some processing, and the response is sent back to the UI, and we show that to the user. Now, what has changed when we say Gen AI part? It's simply the third thing. Okay, so in the backend itself, or even from the front end itself. Okay, so from both of the layer, we specifically call to the chat API, so chat completion APIs, and that's more about the integrating of LLM into the existing app. Or when we say GenAI developer, not much difference. They simply integrate this API call, and that's it. Okay. Even I have seen most of AI apps, they are standard web apps with one extra API call. The AI logic is just one step in our normal backend flow. But the I would say the requirement and other things, they mention a lot of other things. But on the implementation part, you just have to remember that it just adds one more layer of endpoint, that is slash chat and slash completion for most of the LLM models. Okay. So here is an example. So you can try any of the model. Maybe I've given an example of OpenAI, but you can go for any of the example, maybe Gemini or other things. Okay. So most of the cases, the APIs will look like this endpoints that maybe slash chat and slash completion. And this is the request. You mention the model. So this is like, there are multiple flavors of the models. Like, for example, GPT-4. Oh, there are something like mini, there are something like reasoning. So each has a specific purpose. So for example, some models are specifically good on coding type of task. Some models are specifically good on reasoning part. Some are general purpose models. And remember why these different models we should think about, because it has that particular quality of output for us as well. So if the model is, let's say, our question is more of related to, let's say, coding, we should use a coding specific model. Okay. And again, there is also cost differences in these models as well, the way the tokens and the other are considered for the costing. And yeah, okay, coming back to this API response, the messages. So here we basically add something like system prompt and then the user prompt. So when we say system prompt, it is more of related to helping it to understand what we are doing and what we want to achieve. And then in user prompt, you ask the questions from the user, and that's it. So this is the API call that I'm talking about. Okay, now limitations part. Okay, so before that, any questions around this? Okay, uh, let's go from the limitation part. So if you have seen in earlier ChatGPT way, it used to say something like, I know the things till this date, so my responses are related to that part only. So this is generally called as a knowledge cutoff. And why that the case was because, as I said, like the models are trained on heavy data that is available on the internet. So let's say I started training model today, okay, in 2026. And so when I say I started today, it takes some time, let's say 2 months to train and then do the testing and let's say put it into production. So by the time of 2 months, it do not understand like what has happened in these next 2 months, right? So for example, if during this training, I might say that Nifty's level is this today, or maybe I can say that the Iran and US war is Iran and Israel war is going on. maybe after 2 months it might end, let's say. Okay, or let's say, and after 2 months, let's say, we when we release that LLM, and if a user asks like what happened, it will say like the war is still going on, because it do not have any memory or any information what happened after these next 2 months, right? So this is called as a knowledge cutoff. So earlier LLMs were having this drawback. So they were having that exact cutoff time before which they have the memory, they have the I would say knowledge, but after that they aren't they are the limitation, becoming the limitations. Hallucinations, you when you talk about the LLM word, you should use it, because hallucination is something that LLM is just do on generating. I mean, sometimes you have seen in some of the questions you ask ChatGPT, it just generates something. I mean, it's sometimes you feel like it is entirely nonsense thing, or entirely a wrong thing that they have generated, and you get a feeling that hey, LLM and other things are not really good at. For example, uh, in LinkedIn, you have seen a lot of criticism related posts for these LLMs, and say that hey, something like, I have a car, I want to do a washing of the car, and it the car washing center is, let's say, 100 meter from my home. So should I walk, I mean, or should I drive? And the LLM says no, you can simply walk. Okay, so these type of things we have seen on the internet, right? More of related to the criticism, but in reality it's an hallucination, because it, as I said, like it is simply a next generation, or a generation of the next word. It really don't understand much better things unless we specify or give a more context to it. And it is currently drawback as well, hallucination part. And then no company data. So when we say it is trained on certain data, it, for example, our company's internal documents and other things are not there in that LLM as well. So when we wanted to use it, what will be the next solution for these drawbacks? And they are RAG and agent. So you might have heard these words a lot of places. I would say agents nowadays, and this is because the LLMs have these type of limitations. And in order to solve these limitations, we have come up with the wrappers, or a top layers on top of LLMs. Okay, so here is the RAG. Okay, it's nothing but a retrieval augmentation generation. Okay, so let's understand what RAG is. Okay, so in simple word, RAG is search your data plus give context to LLM and then generate the grounding answer. So before LLM answers your question, okay, you search your own documents for the most relevant information. You add that information into the context, and then LLM answers. So this is a kind of three-step process: retrieve, augment, and generate. Okay. So retrieve is something where you provide some of your documents, so that from that documents we try to understand some of the information which is close to the user query. Augment is we try to embed the whatever response that we have, the different I would say search results from our internal documentation into the prompt that we have, and then we feed it to the LLM, and based on this new context and the user query, it generates. So this is the RAG for us. So we need to understand why RAG was there, because we wanted to give LLM a capability to answer our organizations on top of our organization's data as well, right? So for example, if I take an LLM from let's say OpenAI, or let's say uh, a Claude, okay, and if I ask him like, can you review my profile and tell me what should I include in order to make my profile boost in a recruiter, let's say search. Now it might have some general guidelines like, hey, you should have this type of keywords for this year of experience or something else, right? But here it really don't understand your profile. So how you can provide your profile is you probably add your CV and then ask that question to the chat GPT, right? So when we say we add that CV, we basically give our own document to the LLM. Now that document become, now this system will become a RAG. Okay. Now what LLM will do is that when you ask a query like what I need to add so that my profile stand out. So in that context, what it will do, it will try to read your profile. Okay. So it will understand that, hey, so this person has, let's say, 10 years of experience. He has worked on the back end. He has worked on these technologies. He has worked on these type of companies. Okay. So it gets more understanding. Now, during the training, uh, your CV wasn't there, so that LLM don't understand you. But since you have given CV now in the RAG setup, okay, you have given a CV, it understand your own information now, okay. And when you ask a question, what it will do is that, hey, so this person has this type of profile. He is asking me to guide him in this particular query. Now what it will do is that this input profile plus to your query, it will club it into one big prompt, and it will say to fed it to the LLM. Okay. And the LLM will generate some response for you, which is more specific and personalized to your profile. Okay. So that's what the RAG is. So for example, whatever I have seen, there are technical terms to it, but in a very simplistic way, you can think of RAG is a top layer wrapper. Below that, there is a LLM. Okay. Using RAG process, you give context. Using RAG, you give query. And based on that context and the user question, it gives the entire thing in the form of prompt to the LLM which is below that, and then LLM generates something. Okay, so this is let's see the how the technical terms looks like. For example, there are two different ways or two different flows. So when I say I have given my CV, this is the index phase. Okay, so for example, documents, we provide all the documents. Now these documents are rate and split into some of the segments generally called as a chunking. So there are multiple chunking strategies, okay, out there, semantic chunking and other things, which try to split your document into a more or less similar size of paragraphs, but maybe a little bit close enough. For example, it will try to club your one company experience. In case of your resume, it will try to club your first organization's experience in one, let's say, segment, another company in another segment, maybe your other achievements or the college related stuff into another one more segment. So that's how the document is split. And then the embedding. So embedding is more of a technical thing. So we know that whenever we want to store some information, we use database. Similarly, RAG is also, when they want to store this document, they should use some database. In this case, the vector databases are used. So we generally call them as a vector store. And how they are different from our database? So it is more of related to the similarity search finding. So we have database levels like SQL databases, maybe SQL like MongoDB or DynamoDB, right? So they are more of a document related database. We have elastic search kind of search engines, right? Vector store is more of related to the similarity search. Okay, so when we say similarity search, so for example, in case of your CV, it will have, let's say, segmented your experience, okay, into different segments. Now it has created embeddings out of it. Okay, so embeddings is like in the form of vectors, and in a consider, imagine it in a three-dimensional space. Your one of your experience is, let's say, one vector, your another is, let's say, another vector. Now if you ask him like what I did when I was working at X organization, okay, now that query is most similar to the maybe your first organization's split or chunk, right? As compared to your other organization chunk. So that's how that similarity is identified based on user's query and based on your existing document. Okay, so that's what the idea behind using vector store. So what it will do is that Whenever you ask certain query, it will try to find. So in a query phase, so moving ahead to the query phase, when we ask certain question, maybe as I said, like what was my work when I working with this organization. So that question is for turned into the embeddings, and then it try to search what are closed documents to that particular question, or closed chunks, which rather than documents, what are closed chunks related to that particular question. So it will try to fetch these chunks. Now these three chunks, let's say, or x chunks become a context. Your question becomes a query, and this everything is clubbed and dumped in the form of question to the LLM, and it will, hey, so users query is like what I did when I was working with X organization. Here is the context, and in the context it will probably add three chunks, like where this let's say X organization's working experience, I did this, I enhanced this, a lot of things that is there in your CV. Now based on all this information, it will generate some input, some output for you. So that's how the RAG works. So that nowadays, whenever we are chatting with LLMs, okay, we got that RAG capability in it. So you might have uploaded your CV, or you might have uploaded some documents, and then you have asked the questions, right? So this is actually RAG. Earlier it wasn't there. Earlier it was simply a chat interface. Now it is a kind of RAG as well, at least for us when we are using it freely. But in case of organization wide, it might be some implementation on top of that. There are multiple framework and other ways how using which we can implement it. There are different technologies for each of these phase. For example, for vectors, we have databases like Chroma, which is one of the vector store. And there are alternate implementations as well from other vendors. Embeddings, as I said, like there are multiple implementation from various things. We can choose which we want whenever we try to implement it for one of the organization. Okay, so in simple term, RAG and LLM. Okay, so LLM alone is a kind of closed book exam that student can only answer from what they memorized during, let's say, training or during their learning in the semester. Strong on the general knowledge, may be blind to a specific document, may hallucinate when unsure. So these are kind of characteristics when we try to ask answer to the LLM directly, but LLM with RAG is more of an open book. So it's something like when we ask certain question, you can search on the relevant pages. Maybe you can use different materials. You can do searching on other part, and then you come up with some information, and then you uh, write a more precise and correct answers around it. So that's how LLM and the RAG differs. I would say not differ, but it is more of an extension to the LLM. Okay, so that was the RAG part. Now, agents, let's move and look into the agents part. Okay, so before moving that, so we might think that RAG is still a powerful thing to have, then still why we should have one more implementation like the agents, let's say, okay, and what they will actually do and help us with. Okay, so for example, RAG, when we say RAG, it is more of related to the answering question onto the document set that we have. For example, in our example, where we are talking about the CV, or let's say some example which is company related, where we upload a particular policy and ask what this policy says, are we violating something, or something like summarize the document and other things. This is something which RAG will do. Now, think about the task where we want to book a certain ticket. We want to book a meeting on our calendar. We want to do a research on particular topic, or maybe want to see what is the stock price of a particular stock. So in that case, it is more of a real-time things. Okay, even a RAG, it's still a static because LLM was a static. RAG is a kind of static because we are still giving LLM a certain set of document to answer users' queries. Okay, again a static thing. Now, when in real life, in our applications, we exist because we do some real-time work for them. For example, as I said, like booking a movie ticket, maybe searching for, let's say, open hotels, and then probably booking a particular hotel, or even planning an entire journey, like here you can stay, maybe you can book this particular flight and everything. Okay, so all for all this you need to have a way where you can do that real time things as well, and that's where agents comes in. Okay, so the basic idea was to let or give the capability to the agent, to LLM, so that it can also be used for real-time work as well. Uh, Only LLM or cannot be used for this type of stuff. So let's go. Let's take a simple analogy. Okay, think of agent as a human being. The LLM will become a brain of that human, and the tools when we say I want to do XYZ thing. Okay, your brain will do a reasoning around it, and let's say I wanted to move from this particular position to this. The tools, let's say in our case it will be your legs, okay, or maybe hands. Okay, it will do the stuff for us, maybe a lifting or going from one location to another location. Okay, so this is very simple example or analogy you can think of. So this is the general agent architecture. Okay, every agent is given a certain goal to do something. It thinks, and for thinking, it thinking means reason. Reason means like it do come up with certain decisions. This is more of a thinking part. Then the tool is something, so it has thought about doing these things in this way. Now it will need some way to do that particular step. So first party just it thought about, but it have not done anything apart from thinking. Now, in order to make it or take it into the reality or do it actually execute it, it needs some tools. So, for example, tool to let's say call API, tool to search on the internet. For example, while booking a ticket, it might need a tool to call your APIs, right? Your application's APIs to book a ticket. Or let's say in order to search some hotels near, let's say Pune, it might need to search on the maybe Google or maybe search API of some hotel booking sites. Okay, so these are all our tools. And then the observe and repeat. So it it's again whenever we have given a task to ourselves, we also do a repeat and observe loop, right? When we, let's say we search for one hotel, we go into the searching for another hotel, we go into the searching for, let's say, third hotel, we take all the prices, we think about this one has a less price, but this has, let's say, only one room available. Here I can have two different rooms, though the price is little bit higher, but the facilities are good. Okay, so all this thinking, we also do it in a loop. And same set of thinking is thinking, and the mechanism is we are trying to embed into the agent as well. And this is called as a loop. So whenever I given a goal like do a hotel booking for me near Pune for 2 days, it should be good enough to play cricket. Okay, so this is the let's say requirement. That agent, what it will do, it will first search for hotels near Pune. Now it has it will then think no, user wants to have certain ground as well. So it will try to add that information like check whether the ground is available. Then it will try to see like hey, there are let's say 8 people for example. So they probably need a much better hotel or maybe a villa. So it will again try to search for them. Maybe it will think about so user might be having this type of budget. So even though it will try to conclude that hey, we can still pitch the users, hey, you can go 10,000 more but you will get much better outcome out of it. So all these things are doing in a loop. So this is called as a decision and act. So react loop, like reason and act. Okay, and it the just like the way human work, human being or even our brain, and then the way we try to take the decision. Similar thing we try to embed into the machine, and this is called as a agentic loop. Okay, so this is an internal architecture how agent works. Nowadays, there are different frameworks where we don't have to bother about it. We simply give it a goal and it works, it do all the stuff and come up with some of the results to us. Okay, but I'm just explaining so that you have some sense of understanding how that agent is actually made up of, and you can do some analogies to it. So yeah, here is the example. Like I said, the way human has a brain, agent will have a LLM. So it will use its brain. Humans are using his brain to do some decision, take some action, okay, using hands, let's say. Similarly, agents will do the LLM as a brain to do a reasoning part, planning and decision part, tools to basically take that particular decision into the reality. Okay, memory is something the context. Okay, and it is quite analogous to a memory, maybe a short-term memory, long-term memory. Okay, so these are similar to what we think about when you say short-term. We know that what we have maybe had in a breakfast, but if I ask you like what the code changes you have done in one of your PR last year, or even we don't remember whatever we have done last year, right? Even we look at it, we are not sure like whether we have done it or not. So this may be a long-term memory which we might not have. So similarly, the way we have a memory, we consider it as a context in the AI world. And the way we do a retry, like we find one hotel, but we think it's not something which we are really looking at, then we go on searching the next one. Similarly, agent will do this, but we simply call it as a loop. Okay, now what was the next thing? So multi-agent system. So far we have seen the LLM. Okay, so first we have seen the AML DL part, which we have encountered when we were in college. It was more of a theory for us. Later it went into the implementation part, in the form of, let's say, machine learning, deep learning way, then the generative AI part, then the LLM part that we have seen, then the RAG where we have given try to give more context or a local context to LLM, then the agents like how we can give a more capabilities to the LLM. Now the last one is more of around the multi-agent system. Now single agent is still not enough. Okay. For example, if I have a task, let's say related to, I want to pick a best stock in tomorrow's trading day. Okay. Now, what will happen? I will try to have one agent who is really good at research. Now, think about a team working. Okay. Maybe a stock suggestion team, let's say. One person will be really good in a research part. One might be really good in analysis part, and one is really good in doing the decision based on whatever information he has or whatever experience he has. Okay, so we try to replicate similar setup in a agentic world. Okay, so we will try to create an agent only specific to research part. Okay, so it will simply good at researching. It will do a vast amount of data crunching. It will try to read a lot of documents related to the organizations or different, let's say, 100 stocks into the Indian share market. It will try to go into their reports, their quarterly reports, maybe the related news, if there is any fraud, is there any litigations or anything else around it. So its task is to gather as much as information it can gather. Second, maybe an analysis agent where you try to identify, interpret the data, try to spot the patterns, try to understand, hey, when their quarterly profit is going, let's say for this particular quarter, or maybe in the third quarter, they good generally post a better result. So something like that. So is done by the analysis agent. And last one is the decision agent. This decision agent will do a precise decision for you. So it will say that, hey, so based on whatever we have observed so far, I think you should buy, let's say, X stock at this price, and this will be a good buy. And you can sell it at particular, let's say, Y price, and this will be a good sell call. So that type of conclusion will be given by the decision agent. So now think about one agent doing all the stuff, or maybe doing local stuff, versus multiple specialized agents. So which one will perform better? Obviously, the specialized agent. In our reality as well, uh, a normal physician versus a specialized doctors, right? The specialization is something which we prefer. So similar concept we try to build into the agentic world as well. So whatever the context, whatever the prompt. Now, when we say we built a research agent, what it exactly? Uh, it is nothing but a prompt which will say you are a, let's say, research agent. You have this. So in, at the end, everything comes to the prompt. You set up this agent and you add more of a description to it so that it becomes a research agent. So you explicitly say that you are a research agent. You are good at gathering information. You have to read lot of documents on the internet. You can use reading tools. You can use web search tools to do a research. You you have to limit your research till let's say top 100 companies of Indian market. So this type of information is nothing but a prompt, and this type of specific information will make your agents a specialized agents. Okay, and nowadays most popular things are becoming because of that multi-agent system that we have now. The question is, do we really need to write everything from scratch? The answer is no. So think about Spring Boot. We simply write the controllers, I mean, even the address at the rate controller, at the rate, let's say repository, at the rate service, and do our stuff like at the rate post and get, and then simple methods, and it works entire REST API call and its flow. Similarly, there are frameworks like Crew, Autogen, and other, okay, where you can simply even write the agents in a simple text file, even a text document or YAML document, we call it, where you specify the goal, you specify the tools, you specify the other information like context and other things. Okay, and that's it. So basically, you are writing a text document as one agent, and you give that input to your framework, and your framework will understand how we can achieve the goal given. Okay, so that's how the simple frameworks are. We can use them. Now, now the next thing will be where these things are heading. Okay, and something that we should understand, because we, being a developer, we need to understand how LLM world and how the agentic world is going so far, and how it will basically impact us if we don't really want to leverage, or if we want to leverage it. Okay, now from the autonomous coding part, the things that we are saying, they are actually agents. Okay, AI agents that write, run the test, fix the code end to end. So example are Cursor, GitHub Copilot. So you might have seen in your organization that the GitHub Copilot is being used, or even whenever we raise a PR, there are some agentic comments on top of it. We can have options like let's go and fix it. So everything is done by the agentic way. Okay, even in, yeah, even in your IDEs, browsers, even for example Confluence, we have seen that robo option. So it basically try to summarize the page as well. Okay, so everyone is trying to uh, embed the agentic ways, or I would say the LLM ways, into their own apps as well. Even in our emails, Outlook email, we have seen summarize option. So there is a long thread we really don't want to read through. We can simply hit on that summarize option and it will do a summary for us. So it's nothing but a summarizer agent you can think of. And in a behind the scene, what was the prompt for it? It might have prompt like, hey, your task is to summarize this thread, and here is your context. And maybe in a context they might give entire email chain, and then it will generate a summary. So this is how the current state of the AI for us. Now, learning, like how we can really learn it, and what are the places where we should kickstart thing. Okay, now, Hugging Face is something I would recommend. For example, in a GitHub, uh, we have seen a lot of code and other implementation. Similarly, on Hugging Face, you will see a lot of models around it. Okay, maybe a data sets around it, and some certifications and other thing as well. Okay, so on a Hugging Face model, you have a lot of pre-trained models. You can simply, at least for the fun, you can just try to use them, do inference around them. Okay, Spaces is something live demos where people have put their implementation, something like image generators, audio tools, and other thing. Okay, and we can try and use and see how they are working. Datasets, again, it's like a lot of datasets that is available there. Okay, which we can make use of. And then the learn part, it is more of an academy that is there. Okay, okay. Uh, what to learn. For example, on a very simple, simplistic way, to start with, we can look into the how LLM APIs are working, okay, and a prompting part of it, something like calling the Open API or Anthropic API, simple chatbot around it, and some system around prompting and other things. So first phase one is we should directly try as a developer. We should directly try this thing. In a phase two, it is more of an embedding and a rack. It is a next level, I would say. So once you are familiar with the phase one, you can go for the phase two, where you will understand more of related to the rack part, the vector store and other things. You can try to build it locally and do some system which is a question answering system and other things. Third part is like writing an agent, okay? Something like simple agent to do a simple task, and then using framework like Crew AI where you try to build a multi-agent system. Okay, so that's how you can plan your journey if you wanted to go from a backend or let's say full stack developer to something like Gen AI aware kind of developer. Okay. Yeah, what we should skip. Okay, so in the initial part, we have seen the evolutions like machine AI, ML, then deep learning and other things. You can completely skip a lot of stuffs related to that. Maybe going into the details like backpropagation, gradient descent, and other mathematical stuff. They are not needed, not now. So think of something like when we want to use it, Spring Boot framework versus wanted to understand how the bean life cycle is. Okay, we can still use the Spring Boot framework if we don't really know the theory around the beans and other things. Okay, it's good to have, but not absolutely necessary to start with. So similarly, you can at least try to explore the other things and can skip the detailed and theoretical thing around it. Again, GPU training, I mean, it's more of a LLM training. You can skip it because LLM training is something which we will not see most of the time on our job role, or there will be very specific role around it, and mostly into these big giants. Okay, because training LLM is not that simple and not that cost effective. It involves huge cost, needs that expensive hardware as well, and data set as well. So if you try to train it with, let's say, whatever less information that you have with your organization, the output will be less efficient and it's even not readable. Okay, so training is something which you can skip. There are something like a fine tuning you can go for, but only after you complete the initial few phases. And then if you still want to understand, then you can go into the depth of it. And then obviously the model architecture, like the attention mechanism and other thing, the transformer mechanism. So this something which you can skip entirely, at least for now, because our focus should be building something first, like integrating something first into our architectures rather than following the theory to understand how it has been built. You don't need to become an AI researcher. You just need to become an AI aware software engineer.